Hi, I'm Vince Kabinbin and today we're going to solve a problem where strain is related. Here's the example. The composite bar is stress-free before the axial loads P1 and P2 are applied. Assuming that the walls are rigid, calculate the forces acting in each material if P1 is equals to 150 kN and P2 is equals to 90 kN. Given area, elasticity, length of each material. It is said that the load's force acting on the bar is axial, so we need to determine the inner force acting on each member. I'm going to solve for inner force of each material starting from aluminum. So if we cut this part of the aluminum, we can determine the inner force acting on it. Since the force from the wall is against the bar, then we put this R1 here to represent the force on the wall. Now, to make this section equilibrium, we put the inner force here in this direction, so force of aluminum is equal to R1. Since the aluminum is experiencing compressive force, it will shorten by this much. Now, for the steel, if I cut this section, there will be a 150 kN force and R1 in this side. To make this in equilibrium, we put the inner force of steel here. So, the inner force acting on steel is 150 kN minus the R1 tensile force. So, it will experience elongation and it elongates by this much. Now, for the last material, bronze. If we cut the system here, we get 150 kN plus 90 kN minus R1 on this side. And to make this into equilibrium, we put inner force of bronze here. So, we can get inner force of bronze, which is equal to 240 kN minus the R1. The bronze, it will elongate by this much. We now know all the inner force acting on each members, but we don't know yet the exact value of each force because of this unknown R1. So we need another equation to solve for R1. Let's try the compatibility equation. Based on the deformation of each material, I come up with this equation so that we can solve for R1. So, if we substitute all these given values in the equation, we get R1 is equals to 77.60 kN. Now, we can get the inner force on each material. From axial stress resultant earlier, we substitute R1. And then we can come up with these answers.